Does enjoying a few drinks with friends on the weekend really sabotage your hard-earned gains? Are those post-workout beers or cocktails hindering your muscle-building progress? We'll cut through the myths and misinformation to bring you the science-backed facts. Let's get started. But before we move on, make sure to like this video and subscribe to my channel. Ethanol and its metabolic secondary products, such as acetaldehyde, directly affect protein synthesis in skeletal muscle tissue. Main affected muscle fibers are type 2, especially type 2X. It is known that type 2X fibers are those more responsive to hypertrophy. A decrease in basal protein synthesis by 15% to 20% was observed in skeletal muscle after 24 hours of ethanol intoxication. Although ethanol compromised the ability of both insulin and IGF-1 to slow proteolysis. Furthermore, ethanol consumption may suppress protein synthesis slightly via inhibition of exercise-induced mTOR, which is partially dependent on phosphatidic acid from the cell membrane for complex stabilization. Experimental studies also suggest that myostatin increases with ethanol exposure. Myostatin is the growth differentiation factor 8, a potent inhibitor of skeletal muscle and heart growth. Moreover, another study measuring liver protein kinetics has found that in humans bearing a meal of 632 kilocalories with ethanol, 71 grams, reduced the protein synthesis rate by about 30% over the 4 hours measured afterwards. This study also noted that leucine oxidation was reduced by 24%. It was also found, using labeled leucine to measure the fractional secretory rate of hepatic proteins, that a moderate dose of alcohol slightly affect postprandial hepatic protein metabolism by blunting the meal-induced increase in albumin synthesis. A subsequent study confirmed that ethanol, compared to saline control, was able to suppress leucine oxidation at 2 varying doses, and this apparent anti-catabolic action was more effective when no circulating nutrients were present. Research results confirm the detrimental effects of ethanol ingestion on a multitude of physiological levels. Protein synthesis and resulting muscle hypertrophy appears to be directly affected by ethanol. Ethanol and its metabolic subproducts selectively impair IGF-1 signaling via S6K1, that directly affects the transcription of genes involved in muscle hypertrophy, especially in type 2X fibers, those more responsive to hypertrophy. A direct link between ethanol consumption and hormonal profiles is evident. These links indicate that ethanol reduces growth hormone plasmatic levels and alters the pituitary axis by decreasing luteinizing hormone release, which consequently, depending on the dose consumed, could induce a decrease in the level of testosterone. If you want to buy the best quality gym equipments, click on the link in the description.